So we most likely all heard of a channel called Minute Physics. But that's not what we're going to do today. Today we're going to try something called Minute Chemistry. Our topic? The solubility of water. But before we talk about the solubility of water, first let's brush up on our knowledge of water. As we know, water is made up of hydrogen gas plus oxygen gas to make H2O, water. Water to us seems like a very tame substance, so it begs the question, why is water so good at dissolving things? The answer is, water is a polar substance. We can determine if a substance is polar or nonpolar by comparing the electronegativity ratings of the elements that make up the substance. The electronegativity, of course, being a rating of an element's ability to attract other elements. By taking the electronegative charge of oxygen and hydrogen and finding the difference between the two, we can find that the overall electronegative charge of water is 1.24, making it a polar compound. Because water is a polar compound, it has dipoles, which are partial charges that exist on opposite ends of the molecule. Dipoles on a polar compound are indicated using this symbol. When we look at the dipoles on a water molecule, it can be seen that oxygen carries the negative dipole, while the hydrogens carry the positive dipoles. This is because oxygen has the greater electronegative charge, while hydrogens have the weaker electronegative charges. It is important to note that while dipoles are partial charges, they are permanent charges within the compound. It's through these dipole charges that water gains its dissolving properties, kind of like how Superman gains his superpowers from the sun's rays. So we've gone over water and how it gains its dissolving properties, but the question remains, how does water dissolve other substances? To answer that question, we will use the example of water dissolving an ionic compound, in this case, sodium chloride. Take, for example, a cluster of sodium chloride ions held together by their opposite charges. First, water surrounds the sodium chloride cluster. The water molecules line themselves up so that the negatively dipole charged oxygen lines up with the positive charge of the sodium, and vice versa for hydrogen and chlorine. Water molecules use their dipole charges to eventually pull apart the NaCl atoms. It is important to note that while this is happening, the intramolecular bond between the sodium and the chlorine atoms is being broken. Once the individual sodium and chlorine atoms have been pulled apart, the water molecules surround these atoms. Once the water molecules surround the sodium and chlorine atoms, they begin to dissolve the sodium and chlorine atoms. Water dissolves individual atoms by forming a loose bond with them. The process in which water dissolves